Good evening, everyone. It's me coming to you live from my home. And before I get started, let me go ahead and give a couple of disclaimers. Number one, because I am at home, there's a possibility that you may hear a dog bark or walk by. You might even see the dog in the background. I'm not certain. A child might wake up, the phone might ring, my husband might walk in the door. So hopefully none of these interruptions will occur. But in the event that they do, I just wanted to let you know that I might get a little thrown off for a second, but I'll get right back on track. So I'm going to jump right in with where we left off last class period. We went ahead and went over all of the epithelial tissues, and hopefully if you're looking at this right now, you've got your notes, you've got your notebook, you've got whatever you're going to write the information down on, and in addition to that, make sure that you have the handouts. This is the did I get this one? No, this handout is actually already up on Blackboard. So if you need to pause this, go and print the handout so you'll have it with you, that's fine. If not, you can access it later. And once I write all over these, I will eventually later on this evening post what I have written so that you can have clean copies, and then you can also have the one that has the answers on it. So this first one, this isn't the one that I gave out in class, but this first one actually has some of the tissues that we went over. So you can just practice naming those like we did in class today on Wednesday. So that's the epithelial tissue component. We also talked about connective tissue, but remember the only one that we identified was under the connective tissue proper, and that was adipose tissue, and that a fat cell is called an adipocyte, and we talked about the problems with adipose tissue in regard to creating the secondary dilution of our embalming fluid. So from here, I'm going to pick up with still in connective tissue, but we're going to focus on supportive connective tissue. So I'm going to start with this diagram right here at the bottom. But before I get to that, I'm going to write something on my whiteboard. Okay, the diagram that you have on the sheet is what's called an osteon. And actually, there are several osteons within that smear, that smear that you're looking at. However, we need to find out, or we need to know where we can actually access these osteons. Okay, because we're talking about bone, and from the outline that I wrote on the board, you remember beside bone, I also put osseous. Osseous tissue is bone. So therefore, an osteocyte, I hope this is a whiteboard. Yeah. An osteocyte is a bone cell. Okay, an osteocyte is a bone cell. So we're going to talk about where we actually can find these bone cells. I'm doing my best diagrammatic representation of a femur. And there it is. Okay, so this is a femur. The femur is actually the thigh bone. It's the largest and longest bone that we have in the body, but it's also where we can find different types of bone cells, or tissue. So the ends of long bones, because we have other long bones as well, like the humerus, the radius, the ulnar. The ends of these long bones are called the epiphysis, and it's spelled like epiphysis. So that's EPIPHYSIS. The epiphysis are the ends of long bones. Now, the shaft of the bone, which is everything but the ends, also has a name. It's called the diaphysis. The diaphysis is the shaft. Now we have different types of tissue in both the epiphysis as well as the diaphysis. In the ends of long bones, we'll find what we commonly call, and you've probably heard of it, spongy bone. Another name for that, which means the same, is cancellous. Cancellous. Spongy bone, cancellous bone. They are synonymous. That's what we find at the ends of the long bones. Within the shaft of the bone, though, and we call it spongy bone because it looks like a sponge. It's kind of porous. So therefore, thus the name spongy bone. But in the shaft of the bone, we have something that's a little bit more dense. And we call that compact bone. And so it's within the compact bone that we will find our osteocytes or our osteon. So now we're going to start writing on this one. Let me erase my whiteboard for a second. And we'll go right to the diagram. Okay, so here we are. Now I'm going to help you to identify the osteon because it has it labeled here as osteon. Well, what is it really pointing to? Well, if you look at the diagram, you will note that you can kind of see what looks like concentric rings around a darker area in the middle. And then if you look off to the side, it looks like there might be another one, but you can't see it completely in the picture. Let's see this way. All of this that you see right here, this is one osteon. And what you'll note is it looks like you can see another one that's kind of up here. Looks like there's one that's down here, right here. But we're going to focus on the one that we can see in its entirety. That entire unit with all those little dots in it, as well as this darkened circle in the middle, is referred to as the osteon. Each one of these little dark areas here, we're going to draw a line just to one of them. These are the osteocytes. Each one of those little dark, look like little dashes. Those are the osteocytes. Remember, the osteocyte is the bone cell. Okay, now you'll notice that there's a word on your diagram that says lacuna, L-A-C-U-N-A. Now, it looks like it's actually pointing to the osteocyte, but what the lacuna is actually the space that the osteocyte is occupying. So we're going to write our definition. The lacuna is the space that the osteocyte occupies. Give you an example. Right now, I'm sitting in a chair. If you can imagine that I am the osteocyte, well, the chair that I'm sitting in would be representative of the lacuna. So here's the space, the lacuna, and here's the osteocyte that's resting in the space. Okay, let's continue on. Now, as you look at the diagram, you will notice that each osteocyte looks like it has a space right here in between the next grouping of one. Almost like if you were to cut a tree down and you would see the concentric rings of the tree. It's almost as though this is the tree. This is the cut tree, and you're looking at these cells inside of the tree rings. And you will notice that it seems like some cells are lined up on the same ring, while the next group is lined up on the next ring, and then the following group is lined up on the next ring. Well, in between each one of these rings, we kind of have that clear space. You notice that? So right here, I've kind of darkened in this area to indicate that these are the spaces between the concentric rings of the osteon. The spaces between the concentric rings are called the lamella, Lamellae, and they are the spaces between the rings of the osteon. The lamella. And in some of the spaces between the rings, the lamella, you will notice it looks like they're little fine tracings or fine lines that are projecting from one osteocyte to the one that's on the next concentric ring. They actually have a line and an arrow already pointed to it, and that word is called canaliculi. The canaliculi are these small cytoplasmic projections in which one osteocyte can actually communicate with another osteocyte. So, canaliculi, cytoplasmic projections used for communication between osteocytes. All right, and then finally, we have that thing in the middle. That big dark circle is referred to, or it's called, the Haversian canal. You can see that right on the diagram. But it also has other names that it could be called. It could also be called the central canal, or the osteonic canal. And it's within the Haversian central osteonic canal that you will find arteries, nerves, and veins. Okay, so let's look at it like this. Let me give you an analogy to help you understand. If you're looking at your diagram, you're trying to figure out what could I kind of equate this to understand what's going on. Well, let's look at it as if it were the city of Virginia Beach. Okay, the entire picture is the city of Virginia Beach. And just like the city of Virginia Beach, the osteon has several different areas. Just like in Virginia Beach, you've got Salem, Kempsville, Lynn Haven, Bayside, the different areas that are all still within that same city. Okay, so sometimes, particularly in the summertime when we have those really bad thunderstorms sometimes, it might knock out the power to one particular area in Virginia Beach, but maybe not another. So let's identify the osteon that we were working with, this one in the middle. Let's just say that that's the Salem community. And over here, maybe this was Lynn Haven. And right here, maybe Kempsville. Okay, well, every particular community may have its own power source. The power source would equate to the Haversian canal in the center of the osteon, because that's where you got your nerves, your arteries, and veins. They're responsible for keeping everything going. Just like the transformer for any given community is what's responsible for continuing to have the electricity in that particular community. So it could be, just like during the summer months sometimes, where the power might be out in Salem, but it's still good over here in Lynn. Okay, so we can just equate each osteon as its own little community. Okay, so if you're like, all right, can you bring this in for me and bring this on at home? Okay, I'll do that. So you will know the osteocyte in this given community would equate to the houses that are within the community. Get it? There's several houses in Salem, right across the street from the college. That's Salem. That's a whole lot of houses over there. And each house sits on some land. So the house would equate to what? The osteocyte. And the land is what the house sits on. So that would equate to the lacuna. All right. So we've got a whole lot of houses on this street, but that's not the only street in the community. There's a street back here. There's another street right there. So the spaces that are in between the streets in the community would equate to what in our osteon? Where did I put it? There it is. The lamella. And then finally, if I live on this street and I have a friend that lives on the street behind me, instead of walking all the way around there to try to go and speak to her, I could actually just pick up the phone and the lines will allow me to communicate from one street to the next without having to walk all the way around there. So the telephone lines that connect the houses, that allow the people to be able to talk to each other, would equate to the caliculi. And then, of course, our power source, our transformer, would be the haversian or osteonic canal. Bam! There it is. Okay, let's move on. Because now we can go to the next sheet. Where did I put it? Which focuses on vascular connective tissue. Vascular connective tissue is blood. So what we are looking at, and my diagram is a little light. My printer didn't do right. But what we're looking at is a blood smear. Within blood smears, what you should see the most numerous of, and what you see most numerous in this smear that we're looking at on our diagram, are what are called erythrocytes. We talked about this early on. Erythrocytes are red blood cells. And remember, red blood cells do not have a nucleus. They are biconcave discs, and they are responsible for transporting oxygen. Okay. What we also see in this diagram are some larger cells, but they're not as numerous. These are the leukocytes. Now, before I write on the sheet, I'm going to write on my whiteboard because I need to say a little something about the white blood cells. White blood cells, known as leukocytes, are actually categorized into two different categories. We've got the granulocytes and we've got the agranulocytes. Both of them are white blood cells, but the difference is whether or not they have granules within the cytoplasm or kind of inside of the nucleus, or if they do not. The prefix A means not, so obviously the agranulocytes do not have granules within the cytoplasm, and the granulocytes do. There are three types of agranulocytes. We have eosinophil, basophil, and neutrophils. There are only two types of, you know what? Scratch that. Change your heading because I have it backwards. So just take the A off of the agranulocytes because I just gave you all the granulocytes. So let me swap it out. These are the granulocytes. And the agranulocytes are the monocytes and the lymphocytes. Sorry about that. Jumped ahead of myself. There we go. Now it's right. And they look really different. The agranulocytes typically are very large cells with a very large nucleus that pretty much engulfs the entire cell. And as you can see, it doesn't look like there are any granules within the cytoplasm of the cell. While the granulocytes are a little bit smaller, they have a nucleus that looks like it can be bi- or trilobed. And then within the cytoplasm of the cell, you will note these tiny little grains. They are all performing the same function though. They all fight infection. The lymphocytes and the monocytes are typically the ones that get to the site of an infection first. Because they're so large, they have the ability to phagocytize whatever is not supposed to be there. All right, so now we can go back to our diagram. So you will notice that in the diagram that we have, we can see both an agranulocyte and a granulocyte. So, this white blood cell that we see here is a leukocyte, yes, but it's an agranulocyte. While the ones that we see here, here, and here at the bottom, these are your granulocytes. Now the thing about these cells is that we actually really cannot see them because blood is uniform. The way that we would be able to see them is if we were to take the blood, put it into a test tube, and centrifuge it, which means to spin it very, very quickly. All of these formed elements would settle at the bottom of the test tube, while a liquid that's straw colored called plasma would be at the top. The plasma is composed mainly of water, and it nourishes all of the formed elements. Now there's one other thing that we see in the smear. Look like little dots kind of around some of the red blood cells. These are called thrombocytes. Also called platelets. And the function of the platelets is to promote clotting. Give me just 1 second. Okay, so we are now finally finished. Oh, there's the dog. With the connective tissues, and we can now move on to muscle tissue. Well, you will notice that we have 3 diagrams. On the first diagram, please write the word skeletal. That is skeletal muscle tissue. This next diagram, please write smooth beneath it. And then finally, the one at the bottom, obviously that's cardiac. Now, first things first, before we start talking about the differences between the three, we need to understand a couple of terms. Number one, the first one is voluntary or involuntary. If a muscle or if muscle tissue is voluntary, that means we actually have control over what it does. For example, all of the muscles that are attached to our skeleton, for the most part, we have the ability to consciously make them move or make them do what it is that we are required to do. Excuse the dog. And then if we do not have control over a particular muscle tissue, then we call it involuntary. So skeletal muscle tissue, obviously, since I just stated it, is voluntary. While smooth muscle tissue and cardiac muscle tissue are involuntary. No star. Because smooth muscle tissue lines hollow organs like the urinary bladder and the esophagus and the stomach. So we don't really have control over that, and obviously we do not have control over cardiac muscle tissue. Okay? The next thing we need to understand is what's called striated. Striations look like parallel lines that run through the tissue. So if you're looking at the skeletal muscle tissue, hopefully you can see that there are striations. So under that, we're going to indicate that skeletal muscle tissue is striated. Smooth muscle tissue, non-striated. Doesn't even look like it. And if you look very closely at the cardiac tissue, you can also see that it is striated. Next, the skeletal muscle tissue, the tissue is actually parallel, and you'll notice that you can see how it looks like they're right beside one another, laid down side to side. So therefore, we would refer to this tissue as being unbranched. Smooth muscle tissue is unbranched as well. But if you look at the bottom, you will notice that cardiac muscle tissue, while it looks like it's parallel for a minute, you will notice that it does branch, and it branches off into different segments. So under cardiac, we will indicate that it is branched. What we would look for next to determine the difference between the tissue or what type of muscle tissue we're looking at are the number of nuclei per cell. Well, if you look at that picture of the skeletal muscle tissue, you can see darkened areas. There's several nuclei within that tissue. So we will refer to it as being multinucleated. But smooth muscle tissue only has one nucleus per cell. So it would be referred to as mononucleated. And then finally, that cardiac muscle tissue, you'll notice the first word at the top says intercalated disc. The intercalated discs are these dark lines that separate each cell within the tissue. And when we darken them just a little bit, you'll notice that there is only one nucleus per cell because the intercalated discs are segmenting the tissue. So cardiac muscle tissue is also mononucleated. On the diagram at the bottom, You can cross off the word myocyte. You do not need to know that one. But please make sure you understand the concept of the intercalated disc, the striations, and where the nuclei are located. And that finishes with muscle tissue, so we only have nervous left. Okay, so now I'll put up the nervous tissue. Which is really very simple to do. What we are looking at right now, it tells you, is a basic neuron design. A neuron is a nerve cell. And right now, there are a couple of words that I want you to go ahead and kind of X out because you don't need them. You will not need to know, for this course, the myelin sheath, so put an X through that, as well as the node of Ranvier. Everything else we are going to identify. Okay, first things first. You'll notice where it says cell body. Another name for the cell body is the soma, S-O-M-A. They are synonymous. The nerve cells are different than the other cells. You notice that they don't particularly look like the other types of cells. They do not regenerate. And they have what are called dendrites and axons. The function of our nervous system is to take and send nerve impulses all over the body. Therefore, the dendrites are responsible for one conduction and the axon is responsible for the other. Dendrites take nerve impulses toward the cell body. Toward the soma. And typically have a lot of dendrites and then one long axon. Axon starts with A. It takes nerve impulses in which direction? Away from the cell body. So I'm going to make it a little bit darker through here because you notice they kind of take that image of the axon and make it a little larger. The axon takes nerve impulses away. No star. I know. Sorry. All right. So if you notice here, I'll try to make sure. This is the area that they've blown up from here. I tried to make the axon a little bit darker through here, but they've taken this and blown it up over here. All right. Now, finally, if you could just add some dots on the outside of the neuron all the way around it. These little dots that I have just added around the neuron are called neuroglial cells. I'll spell it. Neuroglial cells. Neuroglial cells are responsible for nourishing the central nervous system. That's their responsibility. Oh, there's one last word up there that we did, well, two words, but that's one grouping of words that we need to identify, and that's the axon hillock. The axon hillock is the region where the axon meets with the soma. There's no line or anything, but it's just that region. I kind of circled it right here. just to show you, this region right here is the axon hillock, and it's where the axon meets the soma, meets with the soma. Okay, that takes us to the end. So you have the diagrams that you will possibly see on the quiz. It will either be the nervous system, muscle tissue, or the blood smear. Just word to the wise, I really like the blood smear. Okay. And then you also have the osteon, examples of epithelial tissue, and then the other handout that I gave that I will also post on Blackboard of epithelial tissue. So if you have any questions between now and class, please send me an email. I do check my email over the weekend. I might not get back to you as quickly as I do sometimes during the week, but I will try to respond as soon as possible to any of the questions that you may have. I hope you enjoy the rest of your weekend, and for my Monday class, I'll see you on Monday, and for my Wednesday class, because I decided to post this for you too, anyway, I'll see you on Wednesday. Have a good one.